Welcome to Data Science 1, Probability, Random Variables. Okay, so in the last couple of videos, we've been talking about counting outcomes, enumerating them. Everything is really important. We've talked about a multiplication rule, permutations, and permutations of a subset. We've talked about combinations. Now what we want to do is back up a bit. So we need a little more structure when we think about probability in order to make it easier to work with. Now, looking at outcomes and events alone can be really difficult to deal with because they change from experiment to experiment, and it's not an easy way to look at things. But if we can put just a little bit of structure on this, we can help find some commonalities between our experiments, which will make our data analysis much easier in the end. But the first thing we have to do is define an idea. Okay, and the idea is that of a random variable. And here is sort of the mathematical definition. A random variable is a function, okay? It's not a variable in the sense of like you're used to thinking like x is on the real line. A random variable is a function that goes from our sample space S to the real line. And more formally, you could write this as x is defined to go as a function from S to R. And I know that's abstract and it doesn't really make much sense, but hopefully by the end of this video, you'll understand exactly what it is. So what does this mean? It's really, how do we measure the outcome of our experiment? And what we're going to try to do is, notice we put measure in there. So the idea is, how do we turn our outcome into a number? Okay, we like numbers. Math works really well on numbers. Doesn't work so well on other items. For example, fish. It doesn't work well on fish, okay? But if we are going to go fishing, suppose we want to measure the outcome of our fishing. So right here, we have a fish. How do we turn this fish into a number? Because if I go fishing, I'm going to catch a fish. I'm not going to catch a number, okay? So how do I turn this into a number? Well, there's a variety of ways. We could look at its weight, right? We could sling it up on a scale and measure it and get a number for how much it weighs. We could look at the length, right? There's always that joke. I caught a fish this big, and they hold out their arms really wide, and every time they tell the story, their arms are even wider. So that's one way to turn it into a number. We could measure its length. We could measure the width of it, so we sort of like the top fin to the bottom fin. We could measure that, or we could measure its age. In fish, there's a bone in their skull that's called an otolith. And from that, it has rings on it, like tree rings, and you can count the rings and determine the age of the fish, sort of approximately. But these are different ways that you can turn this fish into a number, okay? And it depends on what you're really interested in, okay? So what if I have more than one fish? What if I went fishing and now I have this? Well, this is different because I went fishing and I want to turn these fish into a number. Okay, well, how could I do that? Well, I could just count the number of fish. There's 1, 2, 3, 4, 5. And then we got 4 here, so we're 9. And then we got 3 more, so we're 12. We got 2 more, so we are at 14. And then 15. So the outcome there could be 15. Or we could put them all together and weigh them all together, right? Throw them all in a net and measure them. Or we could do the weight of the largest fish or the weight of the smallest fish. Okay, the point here is it's how do we turn it into a number? And some things that we need to know is a random variable x is defined by the experimenter to be the attributes that are most relevant to the study. So they're not up for the statistician to pick up. Okay, they're up to the experimenter. What's relevant to them, not relevant to the data that they may have handed off from someone else. Okay, so one thing you should know about random variables, they're not unique. And that's why I tried to show you there's a whole bunch of ways to measure a fish. Okay, so most experiments have a whole bunch of ways you could measure them. Okay, so it often depends on the units of measurement. So if you're measuring with a scale, you might be measuring in grams. If you're measuring with a tape measure, you might be measuring in meters, right? So they have different units of measurement that go with them. And the key thing here is it's considered random because it varies for each trial of experiment in an unpredictable way. Okay, most people I think are familiar with the idea of fishing. You go fishing, you throw your line in or net in, you don't know what you're going to pull back, okay? You don't know. Is it going to be bigger than the last fish, smaller than the last fish, more than the number is more than we had on the last net cast? We don't know. That means it's random in the sense that we can't say that if I do this, I'll get exactly this number. We just know that we're going to have some way of turning this into a number for each of our experimental trials. Now, this simple idea will help us provide us with structure to help understand probability later. And in some of the subsequent videos, we're going to be talking about random variables and what's called their probability distribution. And that's what's going to be in the next video. So we'll see you there.